Okay, so welcome, and in this video we're going to talk about now arc length, but now we're going to talk about what if we have a function in terms of y. So we can derive the same thing, but this time instead of partitioning the x-axis, we're going to partition the y-axis. And so when we do that, we have our g sub y sub I minus 1 to g of y sub I. So that's going to be this direction, right? So we're partitioning this. So this is going to be delta y, and this will be delta x sub I. Okay? And so all we're going to do is we're flipping it around. So what we're going to end up with is if we set up the integral, we're going to end up with this. And of course, if I do the same thing and I multiply the top and the bottom by delta y squared over delta y squared, then what I'm going to end up getting is very similar to the last one, but now I'm going to have a delta y, and then I'm going to have what? I'm going to have 1 plus delta x sub I over delta y squared. And then of course, going further, then I'm going to get the final result, and what I'm going to end up getting is in here, I can choose the sample point, right, x sub x star within each subinterval, and then of course I can use the mean value theorem, and I can say, well, there has to be a point such that the derivative of the function at some point, let's say x sub I star, is equal to the slope, right? Is equal to this slope of the secant line, right? So again, I can get the same result, but this time it's going to be in terms of y. So I get what? I get 1 plus, oops, not f, g of x sub I star, oh, g prime, squared. Oh, delta x. Oh, no, I'm sorry. There we go. And then of course, if we sum up all the values and when you take the limit, then what we result is the arc length is going to equal from C to D. Again, we're talking about in the vertical, let's use C to D. We get the square root of 1 plus g of y prime, g prime of y squared dy. And that's the result. So in the next video, I'm just going to go through the theorem that results from this. Have a great day.